Okay, now tuples and sets. A tuple is just like a list, but you can't change the items in it. It's immutable like a string. Uh, so normally you do a tuple by using parentheses. So this is a tuple, and you can mix data types as the different items in the tuple. It turns out in version 3 plus you can do tuples without the parentheses. The only time you need parentheses if you're representing the empty tuple. To show if it's empty, let's set s equal to an empty tuple, and we'll get the length of the tuple, and you'll see it has 0 elements. But you can do a tuple. I'll say s is equal to quote a 1 true string and the value none. So that actually creates a tuple, and if I do s, you can see it's a tuple and it's got all those elements in it. And the reason they did it so you don't need the parentheses, you can do a very curious thing. Let's suppose we wanted to assign two things at once. So you put a tuple of variable names on the left and say equal, and then a tuple of values on the right. And what happens is it creates the x and y, and it does two assignments corresponding to the tuple elements. So if we look at x and we look at y now, they've been assigned 10 and 20. This is very cool sometimes because you can also return from a method a tuple and use it to assign two things returning from the method. And we might run into that later. Okay, so a tuple is like a list, so it has index. So let's go back to our original, well, let's make a new tuple. And we'll just say 1, 2, 3, 4, 5. So we'll just make it a bunch of numbers, and we'll say t of, get the third element, and it gets the 3. You can do the duplication. So if we have t times 2, we get a new tuple that repeats the original twice. You can do slice. So we can do t slice starting at the third one, going to the fifth one. And so it goes from the number 2 index, which is the third element, up through, but not including the index for 5. So that shows you that. And so that's basically what he shows you in the book here as well. Now, but if you try to change a tuple, so let's see, we have our tuple s, there it is, and let's try to change the true to false. So that's at the 0, 1, 2 index. So we'll say s at 2 is equal to false. And it says tuple object does not support item assignment. That's the same thing we saw with string. So that's really what you need about tuple. Tuples are very efficient, so if you don't need to modify individual elements, you should always use a tuple. So the next thing we're going to look at is a set. And a set is an unordered collection of 0 or more immutable data objects. Now the thing about a set, it's like sticking things into a bag, but it doesn't allow you to put the same thing in once it's already in there. So everything you put in the set has to be unique to each other. If you try to add something to a set that's already in there, it just doesn't do it. So sets are a good way of collecting from a large number of things what are the unique things in it, what are the distinctly unique objects. So to create a set, sets use curly braces. And so we can make a set equal to, let's see, the number is 100, the number 99, the number 3, and the number 45. And so that becomes a set. So we can print it back out. So not very exciting yet. The way you add something to a set is with the add operator. So I can say add, so the add method So we say s dot add, and let's add 99 in again. And you'll see it doesn't really add it. We say s, it doesn't put another 99 in there. So that's the difference between a list and a set, is it has to be unique. There's also no natural ordering. So when I print a set, you're not guaranteed it's going to be in any particular order. In fact, when you look at how it printed out here, it's different than the order that I created it. Okay, now sets can have mixed types. So that's what they have the example here. They have false, they have some float and ints and a string all in the same set. So sets are from math, and the first thing we have membership, which works just like list. You can check if something is in the set. So I can check here, is 99 in the set? And it says true. Is 98 in the set? And it says false. You have the length of the set. So these work just like the other collections. And then we have or, and in this actually, this operator returns a set with all the elements from both sets. So if I have, let's do two sets. So I'll do set 1 is equal to a list of, let's see, Tom, Harry, and Sam. And set 2 will be like a different gathering of people, and there's going to be Mary, Tom is going to be there from the same group that other ones, and let's see, Sam will be there, and Jackie will be there. Oops, what did I do here? S2 is equal to, oh, let's see, colon, Mary, Tom, Sam, Jackie. There we go. So now we have S1 and S2. And if I say S1 or S2, it combines the two sets. So that's called union. It means you take all the unique things from both sets and you combine them and you get a list of all the names. So if this represented the number of people that had went to 2 meetings, it gives you the list of all the people that went to 2 meetings. And then there's the and, which is called union. So this finds the people that only went to both meetings. So if they didn't go to both meetings, they won't be listed. So only Sam and Tom went to both meetings in the 2 sets. There's difference. I use this a lot. Sometimes I send emails out to my students before a class starts, and then I want to send another bunch of emails to students who haven't responded. So I have to track the emails from the people that have responded from the people that from the original list, and that's what difference does. So if we take S2 minus S1, S2, and now remove anyone that's from S1 from S2. So it's going to remove Tom and Sam, and you just have Mary and Jackie left. It works the other way. If I do S1 minus S2, it's different because you're starting with this group and removing everyone that's in this group. So it removes Tom and Sam, and you only have Harry left. And then you can check if all the elements of the first set are in the second set. So let's try S1 less than S2. So that's going to say, is set S1 a subset of S2? And it's not. So let's make a new set. S3 is equal to, let's see, Tom, oops, forgot the curly brace, Tom, comma, and Sam. And you can see Tom and Sam are part of S2, so they're a subset of S2. So now if we say, is S3 less than S2, it should say true. So that's all the operations on sets. And you can also do methods. So you have, instead of using the vertical bar, you can use a set union. So this is the union of 2 sets, the intersection of 2 sets. the difference, and as a subset, these four things are equivalent to these four things here, the operators. And then we showed you add. You can also remove an item from a set. You can pop an arbitrary item for a set. So, for example, if you're playing a card game, you can put all the cards of someone's of a shuffle into a set, and then you can pop it'll randomly pick something from the set, or you can pop it'll randomly pick something from anything that you want, and then you can remove all the elements of a set. So that's sets.